In the freezing January of 1941, while the world burned and America slept, a 59-year-old production chief sat alone in a San Diego hotel room, unable to sleep. He had just witnessed something that horrified him to his core. Not enemy soldiers marching through conquered cities, not bombs falling on civilian populations. He had seen American workers building warplanes the way medieval craftsmen built cathedrals, one painstaking piece at a time, outdoors under the California sun, using methods that belonged in the previous century. And he knew, with the absolute certainty of a man who had spent 4 decades mastering the science of production, that this approach would lose the war before it even started. So Charles Sorensen did something that would change the course of history. He grabbed the notepaper from his room at the Hotel del Coronado, found a pencil, and began sketching through the night. By morning, he had drawn the blueprint for a factory that experts across the aviation industry said was physically impossible. A mile-long assembly line that would build the largest, most complex bomber in the world at the rate of 1 every single hour. His colleagues thought he had lost his mind. The aviation industry laughed openly at his automotive arrogance. Critics would soon mock his dream with a devastating nickname that questioned whether the whole enterprise would ever work. But this Danish immigrant, who had dropped out of school at 13 to work in a stove factory, was about to prove them all catastrophically wrong. This is the story of how the man they called Cast Iron Charlie built the largest factory the world had ever seen, faced public humiliation when it failed to deliver on its promises, watched his closest ally die from the stress of the project, and then silenced every single critic by achieving production numbers that seemed to violate the laws of physics. It is a story of audacity, tragedy, vindication, and the factory that helped win the Second World War. By the spring of 1941, the situation in Europe had grown desperate beyond measure. Adolf Hitler's Wehrmacht had conquered France in just 6 weeks, a military achievement that stunned military experts who had expected the campaign to last years. Britain stood alone against the Nazi war machine, enduring nightly bombing raids during the Blitz that killed tens of thousands of civilians and reduced entire city blocks to rubble. The Royal Air Force had won the Battle of Britain, preventing a German invasion, but the United Kingdom lacked the industrial capacity to take the offensive. German U-boats prowled the Atlantic Ocean in wolf packs, sinking Allied supply ships faster than shipyards could replace them. The Battle of the Atlantic threatened to strangle Britain into submission through starvation. The Third Reich controlled territory stretching from the Atlantic coast of France to the suburbs of Moscow, from the frozen tundra above the Arctic Circle to the scorching sands of North Africa. Hitler's armies seemed invincible. Country after country had fallen before the Blitzkrieg. Norway, Denmark, Belgium, the Netherlands, Luxembourg, France, Yugoslavia, Greece. The Nazi Empire was the largest Europe had seen since the days of Napoleon, and it showed no signs of stopping. President Franklin Delano Roosevelt understood something that many of his countrymen did not yet grasp. American industrial might would ultimately determine the outcome of this global conflict. Tanks and rifles won battles, ships and aircraft won wars, and the nation that could produce the most weapons, the fastest, would eventually prevail regardless of early setbacks. In a fireside chat on May 26, 1940, Roosevelt had stunned the nation by calling for the production of 50,000 combat aircraft per year. This number exceeded the total of all planes built in America since Orville and Wilbur Wright first achieved powered flight at Kitty Hawk, North Carolina, in 1903. It seemed like the desperate fantasy of a politician grasping at straws, but Roosevelt knew that the storm was coming for America too, whether the isolationists wanted to admit it or not. The weapon that would prove essential to Allied victory in the air war was a massive 4-engine heavy bomber called the B-24 Liberator, designed by Consolidated Aircraft of San Diego, California. With a wingspan of 110 feet and a length of 67 feet, the Liberator dwarfed anything that had come before. It could carry up to 8,000 pounds of bombs internally, with external racks capable of boosting that capacity even higher for shorter missions. Its innovative Davis wing design, featuring a high aspect ratio that reduced drag and increased efficiency, gave it speed and range that made it invaluable for missions across the vast expanses of the Pacific Ocean and the submarine-infested waters of the Atlantic. The B-24 would eventually serve in every theatre of the Second World War, flying with 15 different Allied air forces, hunting and destroying German U-boats, supplying resistance fighters in occupied Europe, and raining destruction on enemy factories, oil refineries, and military installations. But there was a critical problem that threatened to undermine everything. Consolidated Aircraft was building Liberators using the same methods the aviation industry had always employed, methods that amounted to elaborate handcraft work. Workers assembled planes outdoors on steel fixtures, using surveying equipment and hand tools. The California sun warped the metal jigs, making precise alignment impossible. No two bombers came out exactly alike, because no two could be built under identical conditions. It took 4 hours just to hang a single engine onto the wing. At this pace, America would need decades to build the air fleet necessary to defeat the Axis powers. The nation desperately required a revolution in manufacturing, and that revolution would emerge from the most unlikely source imaginable. Charles Emil Sorensen was born on September 7, 1881, in the Danish capital of Copenhagen. His father Soren worked as a model maker, a skilled trade that involved creating precise wooden patterns used in metal casting. It was exacting work that demanded patience, precision, and an intuitive understanding of how materials behaved under different conditions. This family trade would shape young Charles in ways neither father nor son could have imagined during those early years in Denmark. When Charles was 4 years old, the Sorensen family joined the great wave of European immigrants seeking opportunity in the New World, settling first in the American heartland before eventually making their way to the industrial cities of the Northeast. The Sorensens were not wealthy. They possessed no family fortune, no prestigious connections, and no educational advantages. They moved frequently, following work wherever it could be found, scraping together enough to survive while dreaming of something better. Charles attended school in Buffalo, New York, but his formal education ended abruptly at the age of 13, when economic necessity forced him to leave the classroom and enter the workforce. He apprenticed as a pattern maker at the Jewett Stove Works, learning the trade that his father had practiced in the old country. It was brutal, physical labor. The young immigrant worked with molten metal, breathing fumes that would kill lesser men. He crafted wooden patterns that would be used to cast iron components for stoves, learning through endless repetition the fundamental relationship between design and production, between the idea of a thing and the reality of making it. There were no textbooks in this education, no professors delivering lectures, no diplomas waiting at the end. Young Charles Sorensen learned from fire and iron and the calloused hands of men who had spent their entire lives working with metal. He learned that theory meant nothing if you could not translate it into physical reality. He learned that the only things that mattered were results. When his father moved to Milwaukee in 1898, Charles followed and continued working under his supervision, while simultaneously teaching himself the mathematical foundations of engineering through correspondence courses. He studied drafting, algebra, geometry, and trigonometry through the mail, doing his lessons at night after exhausting days in the foundry. He had no credentials, no formal qualifications that would impress anyone reviewing his background, but he possessed something that no amount of formal education could provide, an intuitive, almost instinctive understanding of how things are made and how they could be made better. In 1900, the Sorensen family relocated once again, this time to Detroit, the city that would soon become the center of the automotive revolution that would transform American life. Charles found work at a custom foundry, continuing to hone the skills he had developed since childhood. And it was there, in that Detroit foundry, that fate intervened in a way that would change not just his own life, but the entire trajectory of industrial civilization. He met a man named Henry Ford. Ford was a strange and driven inventor, obsessed with an idea that most practical men dismissed as a fantasy. He wanted to build a horseless carriage, an automobile, that ordinary working Americans could afford to purchase. At the time, automobiles were expensive toys for the wealthy, hand-built luxury items that cost more than most families earned in years. Ford believed that mass production could change that equation entirely, that if you could make enough cars fast enough, the price would fall to a level that farmers and factory workers could manage. Ford recognized something in the young Danish immigrant, a shared obsession with efficiency, a willingness to work without rest until a problem was solved, an absolute refusal to accept that anything was impossible, simply because it had never been done before. In 1905, Ford hired Sorensen as a pattern maker, bringing him into the small company that would soon reshape the modern world. Within just 2 years, the immigrant who had never finished high school was running Ford's entire pattern department. What happened next would transform not just the automobile industry but all of modern manufacturing. On a Sunday morning in July of 1908, at the Ford Piquette Avenue plant in Detroit, Sorensen decided to test an idea that had been forming in his mind for years. The standard practice in manufacturing was to bring workers to stationary products. Teams of craftsmen would gather around a vehicle frame, each performing different tasks, moving from car to car as their particular skills were needed. It was inefficient. It wasted time. It produced inconsistent results. What if, Sorensen wondered, you reversed the equation entirely? What if instead of moving workers to vehicles, you moved vehicles past workers? That Sunday, Sorensen and a colleague named Charles Lewis conducted an experiment that would revolutionize industrial production. They dragged an automobile chassis through the factory, while other workers stationed along the route added parts as the chassis passed their positions. The results exceeded anything Sorensen had imagined. This early experiment demonstrated the fundamental principle that would later be refined and perfected. The moving assembly line, the invention that would define 20th century manufacturing and make possible the mass consumer society, was conceived in that moment. By 1913 and 1914, the fully developed system at Highland Park had reduced final assembly time from over 12 hours to just 93 minutes. Henry Ford received the credit for this innovation, as he always did for anything good that happened at his company. But the men who actually worked at Ford Motor Company knew the truth. Charles Sorensen had fundamentally reimagined how complex products could be manufactured. He had proven that continuous motion, standardized parts, and specialized labor could multiply productivity beyond anything previously achieved. Over the following 3 decades, Sorensen rose steadily through the Ford hierarchy to become the company's production chief, the man responsible for translating Henry Ford's visions into physical reality. He oversaw the construction and operation of the legendary River Rouge complex, an industrial cathedral where 100,000 workers could transform raw materials, iron ore, and rubber and glass, into 10,000 finished automobiles every single working day. He helped develop the Model T, the $5 workday that created America's middle class, and the sophisticated V8 engine that required revolutionary casting techniques to produce affordably. Sorensen earned a reputation for brilliance and for ruthlessness in equal measure. He drove himself without mercy, working punishing hours that would have destroyed weaker men. And he drove everyone around him with the same relentless intensity. Subordinates who could not meet his standards were discarded without sentiment. Colleagues who challenged his methods found themselves on the losing end of brutal corporate battles. Workers on the factory floor gave him a nickname that captured both his expertise in foundry work and his uncompromising, unforgiving personality. They called him Cast Iron Charlie. By 1940, Charles Sorensen had spent 35 years perfecting the art and science of mass production. He had helped create the Model T, the $5 day, the River Rouge plant, and the flathead V8 engine. He was approaching 60 years old, a wealthy man with a legacy that would secure his place in industrial history. He believed his greatest achievements were behind him, that he had done everything he was meant to do. He was completely, utterly wrong. His most important work had not yet begun. Do you think business leaders today would have the courage to attempt something as radical as what Sorensen proposed? Share your thoughts in the comments below. When the Roosevelt administration approached Ford Motor Company in early 1941 about manufacturing components for the B-24 Liberator bomber, Sorensen was dispatched to San Diego to inspect Consolidated Aircraft's production operations. What he witnessed there appalled him beyond anything he could have anticipated. The aircraft manufacturer was building these enormous, sophisticated war machines outdoors, fully exposed to the elements. Workers used handheld surveying equipment to align components, the same basic technology that railroad surveyors had employed in the previous century. The California sun beat down on the steel fixtures that held aircraft sections in position, warping the metal and making it physically impossible to produce two identical planes. 4 hours were required just to install a single engine onto the bomber's wing. Mechanics used methods that seemed designed for maximum inefficiency, gathering around each aircraft like craftsmen around a custom project, moving from plane to plane without any systematic organization. Sorensen saw immediately, and with complete clarity, that this approach could never produce aircraft in the quantities that the coming war would demand. As he later wrote in his memoirs, they were producing a custom-made plane put together as a tailor would cut and fit a suit of clothes. No two were alike. The aviation industry had spent decades developing this approach, and its practitioners defended it with the fervor of religious believers protecting sacred doctrine. But Sorensen knew better. He had spent his entire career proving that mass production methods could be applied to any product, no matter how complex. When he expressed his concerns to the consolidated executives, they pushed back with barely concealed contempt. Automobile manufacturing was one thing. Aircraft manufacturing was completely different. These were sophisticated machines requiring precision that automotive plants could never achieve. The variables were too complex, the tolerances too tight. Building bombers like cars would result in aircraft that fell apart in the sky. How would you do it better? They challenged him. That night at the Hotel del Coronado, facing the Pacific Ocean that would soon become a vast battlefield, Charles Sorensen could not sleep. His mind raced with possibilities, with calculations, with the vision of what could be accomplished if the right methods were applied. Yes, a B-24 Liberator bomber was vastly more complex than an automobile. The aircraft contained nearly 500,000 individual parts, far more than any car ever built. Its mechanical, electrical, and hydraulic systems were intricate beyond anything the automotive industry had ever attempted. A single misaligned rivet could cause a bomber to disintegrate at 30,000 feet. But the fundamental principles of mass production should still apply. Break the product into major subassemblies. Break those subassemblies into smaller components. Standardize every single part to interchangeable tolerances. Move those components along a production line in continuous motion. Bring the work to the workers in a relentless, unending flow. Eliminate wasted motion, wasted time, and wasted effort. Sorensen grabbed the hotel notepaper and began sketching furiously. He drew line after line, station after station, translating decades of manufacturing experience into a radical new vision for aircraft production. The B-24 would be built in 11 major sections, each section assembled from 69 smaller subassemblies, each subassembly built from standardized components, produced with the precision that Ford had brought to automobile manufacturing. Everything would move along twin parallel assembly lines stretching for more than a mile, the longest production lines ever constructed. By morning, bleary-eyed from lack of sleep but burning with conviction, Sorensen had outlined an assembly process that would treat the B-24 the same way Ford treated automobiles. He had sketched a factory that would dwarf anything the world had ever seen, and he had made a promise that would haunt him for years before it was finally vindicated. Ford Motor Company would build complete B-24 Liberator bombers at the rate of 1 per hour. When Sorensen showed his sketches to Edsel Ford over breakfast the next morning, the younger Ford immediately understood their revolutionary significance. Edsel was everything his father Henry was not. A gentle and cultured man who appreciated art and design, a forward-thinking executive who understood that the company needed to modernize. He had spent his entire career trying to drag Ford Motor Company into the 20th century, while simultaneously navigating the treacherous relationship with his domineering, increasingly erratic father. Now he saw an opportunity for Ford to serve the nation in its hour of need, while demonstrating what American mass production could truly accomplish when unleashed. Edsel assured Sorensen that Ford Motor Company would build such a plant. He gave his complete support without hesitation. The two men presented their audacious plan at a meeting with Consolidated Aircraft and Army Air Forces officials later that same day. Sorensen proposed that Ford would not simply manufacture components for other companies to assemble at their own facilities. Ford would build complete B-24 bombers, from raw materials to flight-ready aircraft, at the revolutionary rate of 1 per hour. Every hour, every day, until the war was won. The aircraft industry representatives in that conference room were stunned into disbelieving silence. 1 plane per hour? 1 complete 4-engine heavy bomber every 60 minutes? The idea was preposterous. It violated everything they understood about aircraft manufacturing. It ignored the complexity, the precision, the specialized skills that building warplanes required. This automobile executive had clearly lost his mind, but the Army Air Forces was desperate enough to take the gamble. The war situation was deteriorating rapidly. Britain needed help. The Pacific was about to explode. America would need thousands, tens of thousands of bombers to defeat the Axis powers. In February 1941, the Army awarded Ford Motor Company a contract to produce B-24 Liberator bombers. The company began construction immediately on a massive factory complex west of Detroit, on flat Michigan farmland owned personally by Henry Ford, near a small creek with an unassuming name. The creek was called Willow Run. That name would soon become famous around the entire world. The architect Albert Kahn, who had designed many of Ford's previous manufacturing facilities, including the River Rouge plant, translated Sorensen's overnight vision into physical blueprints and construction documents. This would be Kahn's final major industrial project before his death in December 1942. The numbers involved were almost incomprehensible in their scale. The main building would contain 3.5 million square feet of manufacturing floor space, making it the largest industrial building under a single roof anywhere on the face of the earth. The assembly lines would stretch for more than a mile, longer than any production lines ever constructed, featuring twin parallel tracks that could produce aircraft simultaneously. The design included a peculiar architectural feature that would become famous in manufacturing history. 2/3 of the way along the assembly lines, the factory made a sharp 90-degree turn, giving the building its distinctive L shape when viewed from the air. This unusual configuration allowed Ford to keep the entire manufacturing facility within Washtenaw County, thereby avoiding the significantly higher property taxes of neighboring Wayne County, which had threatened a tax of $2 per aircraft. The turn required the installation of massive mechanical turntables that would physically rotate the partially completed bomber fuselages before continuing them toward final assembly. Construction began in late March of 1941, with formal groundbreaking on April 18th. 5 major contractors worked simultaneously in a race against time that few Americans fully appreciated. The plant went up in sections, with construction crews using plywood partitions to seal off finished areas from those still under construction, allowing production to begin even while the building itself remained incomplete. Ford's commitment to the project was absolute and total. Henry Ford, despite his well-known isolationist political beliefs and his vocal opposition to American involvement in European affairs, refused government financing for the Willow Run plant. He preferred to build the factory using Ford Motor Company's own funds, then sell the completed facility to the federal government, which would lease it back to Ford for the duration of the war. Adjacent to the main manufacturing complex, Ford constructed a massive airport specifically designed for testing completed bombers before they were delivered to the military. The Willow Run Airport covered 1,484 acres and featured 6 full-length runways capable of handling the heaviest aircraft of the era, along with 3 enormous hangars for aircraft maintenance and preparation. The largest of these hangars could accommodate 20 B-24 Liberators simultaneously and included a control tower, a cafeteria for workers and flight crews, and even a small hotel where pilots could rest before ferrying completed bombers to their assigned military units. Bombers rolling off Sorensen's assembly line could be flight tested immediately and then flown directly to combat zones anywhere in the world without ever leaving Ford facilities. On October 22, 1941, the Willow Run bomber plant was formally dedicated in a ceremony attended by dignitaries, military officials, and Major Jimmy Doolittle of the United States Army Air Forces. Doolittle was already famous for his aviation achievements and would soon become legendary for leading the daring April 1942 bombing raid on Tokyo that proved Japan itself was vulnerable to American air power. His presence at the dedication signaled the importance that military leaders placed on Willow Run's potential. Just 7 weeks after that dedication ceremony, on December 7, 1941, Japanese naval aircraft attacked the American Pacific Fleet at Pearl Harbor, Hawaii. The United States was suddenly, irrevocably at war. The theoretical need for heavy bombers immediately transformed into an urgent national emergency. Every plane that Willow Run could produce would be desperately needed. The clock was now running against the survival of civilization itself, but building the largest factory in the world was only the beginning of Sorensen's challenges. His engineering teams faced a problem that nearly defeated the entire enterprise before a single bomber could roll off the assembly line. Consolidated Aircraft, which had designed the B-24, had never created proper engineering documentation for the aircraft. The blueprints and drawings that existed were incomplete, inconsistent, and filled with discrepancies, unfamiliar symbols, and outright contradictions. Crucial information about how components fit together existed only in the memories of experienced foremen at the San Diego plant, knowledge that had never been written down because the craftsman approach to aircraft manufacturing had never required formal documentation. Sorensen's response to this seemingly insurmountable obstacle was characteristically aggressive and comprehensive. He arranged for 2 complete B-24 Liberator bombers to be flown from California to Dearborn, Michigan, where Ford engineering teams systematically dismantled them piece by piece, documenting every single component, every fastener, every wire, and every rivet. A tool design group numbering over 1,000 engineers and draftsmen worked around the clock, 7 days a week, for nearly an entire year. They generated 5 million square feet of engineering blueprints, creating detailed 3-dimensional schematics for each of the bomber's 30,000 separate parts. This documentation guided the custom design and fabrication of 1,600 specialized machine tools and 11,000 custom fixtures, some standing 60 feet tall, that would stamp, mill, drill, broach, and grind components to tolerances measured in thousandths of an inch. Every single part had to be precisely interchangeable so that any component from any production run would fit perfectly with any other component from any other run. This was the foundational principle of mass production, and achieving it for an aircraft as complex as the B-24 required an engineering effort without precedent in aviation history. But even as Ford's engineers worked frantically to document and standardize the B-24 design, Consolidated Aircraft kept changing it. The original contractor made modifications constantly, incorporating improvements suggested by combat experience, responding to feedback from flight crews, adapting to changes in enemy defenses. Every design change, no matter how minor it seemed to the aircraft engineers in San Diego, required expensive and time-consuming updates to Ford's carefully calibrated production line. Fixtures had to be redesigned, machine tools had to be reconfigured, workers had to be retrained. The numbers were devastating. 10,000 of the 30,000 engineering drawings that Ford teams created became obsolete before they could even be used in production. Ford's entire manufacturing philosophy depended on standardization, on making thousands of identical parts that would fit together perfectly in final assembly. But the product itself kept shifting beneath their feet like sand on a beach. Sorensen assembled an engineering and production team unlike anything he had ever worked with before in his decades at Ford. These were not simply automotive experts who could transfer existing knowledge to a new product. He recruited metallurgists who understood the specialized aluminum alloys used in aircraft construction. He hired aeronautical engineers who could interpret the complex structural requirements of airframe design. He brought in production specialists who had to learn an entirely new industry, while simultaneously trying to teach that industry the principles of mass production. The cultures clashed constantly and sometimes violently. Aircraft manufacturers had always prioritized precision, customization, and the accumulated expertise of skilled craftsmen who understood the unique requirements of flight. Automotive manufacturers prioritized speed, volume, and the standardization that made high production rates possible. Finding the balance between these fundamentally different philosophies nearly destroyed the entire Willow Run enterprise. The workers who would staff this enormous factory came from everywhere. Michigan had never seen anything like the migration that followed Ford's announcement of high-paying war production jobs. The company recruited aggressively from across the country, especially from economically depressed regions of the South, promising steady employment, good wages, and the satisfaction of contributing to the war effort. By the end of 1943, more than 42,000 workers were employed at Willow Run, making it one of the largest concentrations of manufacturing labor anywhere in the United States. But those workers needed places to live, and there were none available. Housing construction had essentially stopped during the Depression years, and the sudden influx of tens of thousands of people to rural Michigan completely overwhelmed the existing infrastructure. Every spare room between Ann Arbor and Detroit was rented, often at inflated wartime prices. Workers commuted 100 miles each day to reach the plant because no housing closer could be found. Some slept in their cars in the Willow Run parking lots, catching a few hours of rest between shifts. The federal government eventually intervened to address the housing crisis, constructing Willow Village, a makeshift instant community that grew to include 30 dormitories, endless rows of small prefabricated houses, commercial buildings with shops and services, police and fire stations, schools for workers' children, and all the other infrastructure required by a population that eventually exceeded 15,000 residents. An additional 1,000 trailer homes were installed when even this construction could not keep pace with the flood of incoming workers. Willow Village was not elegant or permanent, but it allowed production to continue. Do you believe modern industries could mobilize this kind of workforce transformation in a crisis? Let me know your perspective in the comments. On September 18, 1942, President Franklin Delano Roosevelt and First Lady Eleanor Roosevelt visited Willow Run, touring the massive facility in the company of Henry Ford, Edsel Ford, and Charles Sorensen. The presidential party traveled in Roosevelt's specially modified 1939 Lincoln, known as the Sunshine Special. The president understood the profound symbolic importance of this plant. He had called American industrial capacity the arsenal of democracy, arguing that the nation's factories would produce the weapons that free peoples would use to defeat tyranny. Willow Run perfectly embodied that vision, a single facility dedicated to producing the heavy bombers that would carry the war to the enemy's homeland. The presidential visit generated enormous publicity and raised public expectations to stratospheric levels. Americans read in their newspapers and saw in their newsreels that Ford Motor Company was building an aircraft factory of unprecedented size and sophistication. They heard the promise that bombers would roll off the assembly line at rates never before achieved in aviation history. They believed that American industrial genius would quickly overwhelm the Axis war machines, but the plant was not delivering on those promises. The first complete B-24 Liberator, manufactured entirely at Willow Run, rolled off the assembly line on October 1, 1942, and was christened the Spirit of Ypsilanti in honor of the nearby Michigan town. It should have been a moment of triumph, the vindication of Sorensen's vision. Instead, it marked the beginning of a humiliating period that would test everyone involved to the absolute limits of human endurance. Production rates were painfully, embarrassingly slow. The bold public promise of one bomber per hour seemed like a cruel joke, an automotive executive's fantasy that had crashed into the reality of aircraft manufacturing. Month after month, the numbers remained far below targets. The gap between what Sorensen had promised and what Willow Run actually delivered widened into a chasm. By early 1943, critics had discovered a devastating way to express their contempt for the struggling plant. They began calling the facility Will It Run instead of Willow Run, a mocking play on words that captured the growing doubt about whether Ford's ambitious project would ever succeed. The nickname spread through newspapers, popular magazines, congressional hearing rooms, and factory floors across America. The negative publicity threatened to undermine public confidence in the nation's entire industrial war effort. If Ford Motor Company, the legendary pioneer of American mass production, the company that had built the Model T and the River Rouge plant, could not make this work, what hope was there for anyone else? Senator Harry S. Truman of Missouri visited Willow Run on April 13, 1942, and returned on February 20, 1943. Truman headed the Senate Special Committee to investigate the National Defense Program, commonly known as the Truman Committee, which was charged with identifying and eliminating waste, fraud, and profiteering in war production contracts. The committee would ultimately save the government an estimated $10 to $15 billion during the war. Truman was a tough, no-nonsense investigator who could not be fooled by corporate excuses. Truman was distinctly unimpressed by the explanations he heard at Willow Run about design changes, engineering challenges, workforce difficulties, and production learning curves. He had visited factories across the country that were meeting their commitments despite similar obstacles. He wanted finished bombers flying to combat zones where American airmen were dying for lack of adequate equipment. He wanted results, not excuses. His visits and his subsequent public comments added to the pressure, crushing everyone associated with the plant. Edsel Ford, the man who had first approved Sorensen's vision and had championed the bomber project from its inception, worked himself to complete physical exhaustion trying to solve Willow Run's cascading problems. For years he had suffered from severe stomach ailments that his doctors attributed to the impossible stress of his corporate position, perpetually caught between his aging father's increasingly erratic demands and the urgent need to modernize the company for 20th century competition. Now the crushing pressure of wartime production, the public criticism, the congressional investigations, and the weight of national expectations compounded all his existing health problems beyond anything his body could withstand. Medical examinations in 1943 revealed tumors growing in Edsel's stomach. His doctors delivered a grim prognosis and warned him in the strongest possible terms that continuing to work at his current pace would endanger his life. They told him he needed to step back, to rest, to allow others to carry the burden. Edsel Ford refused. The plant demanded his leadership. The nation was at war. Young American men were flying into combat in aircraft that his company had pledged to build. He could not abandon his post while soldiers were dying on battlefields across 2 oceans. He kept working. On May 26, 1943, Edsel Bryant Ford died from stomach cancer and undulant fever at his home in Grosse Pointe, Michigan. He was 49 years old. He never lived to see Willow Run fulfill the promise he had embraced that morning in San Diego when Sorensen showed him sketches on hotel notepaper. The gentle, cultured executive who had believed in the vision from the very beginning, who had given Sorensen the support he needed to attempt the impossible, was gone. His death left a hole in the Ford organization that would never truly be filled, and it removed from Charles Sorensen his most important corporate ally at the worst possible moment. The turning point that finally transformed Willow Run from embarrassing failure to triumphant vindication came through a convergence of factors that aligned in late 1943 and the early months of 1944. Each element was necessary. None alone would have been sufficient. Together, they finally allowed Sorensen's original vision to function as he had designed it. At the urgent request of the federal government, Ford Motor Company decentralized Willow Run's operations, farming out component manufacturing to other Ford facilities and to a network of subcontractors spread across the country. The main plant could then concentrate exclusively on what it did best: the final assembly of complete aircraft from components and subassemblies that arrived ready for installation. This division of labor reduced complexity and allowed each facility to specialize. The constant design changes from consolidated aircraft finally stabilized as the military standardized on the B-24J model as the primary production variant. For the first time since production began, all 5 members of the Liberator production pool, the consortium of manufacturers building B-24 seconds at different locations across America, would produce aircraft under the same designation with the same specifications. Sorensen's assembly line could finally operate the way it had been originally designed to function, with standardized parts flowing in predictable sequences toward predetermined junction points. Complete operational control of the Willow Run plant was consolidated under a single manager who possessed clear authority over all aspects of production. The bureaucratic tangles and competing chains of command that had paralyzed decision-making were eliminated. The red tape that had strangled operations for years was cut. Suppliers, engineers, and quality inspectors finally aligned against a single, common objective: producing bombers as fast as humanly possible. The workforce underwent its own transformation as the war continued to consume American manpower. As millions of men were drafted into military service and shipped overseas to fight, women took their places on factory floors across the nation. By May of 1942, 15% of Willow Run's workforce consisted of women performing jobs that had been exclusively male territory just months earlier. That percentage continued climbing throughout the war years. At peak production, up to 1/3 of all workers at the plant were women, operating rivet guns and welding equipment and precision machinery alongside the men who remained. These women came from every background imaginable. Housewives who had never worked outside their homes, teachers and nurses seeking higher wartime wages, farm girls from rural Michigan looking for opportunity in the industrial economy, and women like Roswell Monroe. Monroe was born in Pulaski County, Kentucky, in 1920. She grew up in a large family, one of 9 children, and proved herself handy with tools from an early age. When her husband was killed in a car accident, leaving her a young widow with 2 small children to support, she did what millions of Americans were doing in those desperate war years. She moved to Michigan to take a job at the Ford bomber plant, joining the great migration of workers flooding into the arsenal of democracy. At Willow Run, Roswell Monroe worked as a riveter, operating a pneumatic rivet gun to fasten the aluminum skins that formed bomber fuselages. It was demanding physical labor, requiring strength, precision, and absolute concentration. A single misplaced rivet could compromise the structural integrity of an aircraft carrying 10 young men into combat at 30,000 feet. The women who performed this work understood exactly what was at stake. On January 21, 1944, the actor Walter Pidgeon came to Willow Run to film a promotional documentary encouraging Americans to purchase war bonds. The song Rosie the Riveter had already become a cultural phenomenon, written in 1942 and inspired by other women defense workers. When producers learned there was an actual woman named Rose working as a riveter at the plant, they recognized the perfect opportunity to bring the symbol to life. Monroe appeared in the film, becoming one of several women who came to personify the Rosie the Riveter image that would endure for generations, representing the millions of American women who supported the war effort through industrial labor. The spring of 1944 brought the vindication that Charles Sorensen had promised and that critics had spent years mocking as automotive fantasy. In March of that year, workers at Willow Run, operating in 2 9-hour shifts, 6 days per week, produced 453 complete B-24 Liberators in just 468 working hours. The mathematics were undeniable. One finished heavy bomber rolled off the assembly line every 63 minutes. Charles Sorensen's outrageous, impossible boast was no longer an empty promise or a propagandist's exaggeration. It was documented, verified, industrial fact. At its absolute peak performance, the plant achieved even more remarkable efficiency. Ford refined operations until a completed B-24 rolled off the line every 55 minutes. The factory that newspaper columnists had mocked as Will It Run was now outproducing every other aircraft manufacturing facility in the United States of America. A single Ford plant was manufacturing nearly as many bombers as 4 traditional aircraft companies combined. The mile-long assembly line that Sorensen had sketched on hotel notepaper in that sleepless San Diego night was functioning exactly as he had envisioned. Fuselages, wings, tail sections, and engine assemblies flowed toward each other on the twin parallel production tracks like tributaries joining a great river. At precisely planned junction points, subassemblies merged and mated into recognizable aircraft. Quality inspections occurred in continuous motion, synchronized with the relentless forward progress of the line. At the end of the mile, completed B-24 Liberators rolled through the massive hangar doors, 32 feet tall and 150 feet wide, onto the concrete runways of Willow Run Airport for testing and delivery. By 1945, Ford was producing 70% of all B-24 Liberators manufactured in America, doing so in just 2 daily production shifts. The skeptics who had laughed at Sorensen's vision, the aviation experts who had insisted that aircraft could never be built like automobiles, the critics who had given Willow Run its mocking nickname, all were silenced by the undeniable reality of bombers rolling off the line faster than anyone had believed possible. But Charles Sorensen, the man who had conceived this miracle, who had sketched its design on hotel notepaper, who had endured years of criticism and doubt and public humiliation, would not be present at Ford Motor Company to witness the final triumph. On March 13, 1944, just as Willow Run reached its peak production and vindicated everything he had promised, Sorensen's 40-year career at Ford was over. The circumstances of his departure were tangled in the complex, often poisonous internal politics of Ford Motor Company during its founder's declining years. Henry Ford, approaching 80 years old, had suffered multiple strokes and was sinking into senility. His mental faculties were failing, his judgment had become erratic and unreliable, but he refused to relinquish control of the company he had built. Into this vacuum of leadership rushed Harry Bennett, Ford's longtime head of the service department, the corporate security force. Bennett was a tough former Navy boxer who had served from 1909 to 1916 and competed in amateur bouts. He had built a private empire within Ford, commanding a network of enforcers and investigators who reported directly to him. As Henry Ford's mental capacity declined, Bennett accumulated more and more power, positioning himself as the old man's gatekeeper and enforcer. Sorensen and Bennett had maintained an uneasy alliance for years, united by their shared service to Henry Ford, even as their methods and personalities clashed. But Edsel's death in 1943 eliminated the moderating influence that had kept Ford's feuding executives in some semblance of cooperation. The company descended into internal warfare over who would control its future. Sorensen took a position that would prove professionally fatal. He aligned himself with Edsel's eldest son, the young Henry Ford II, who had been released from Navy service and brought back to Dearborn to learn the family business. Sorensen believed that the company's future required a transition to the next generation of Ford leadership. This put him in direct conflict with Harry Bennett, who had his own plans for controlling Ford after the elderly founder's inevitable death. The power struggle within Ford Motor Company became vicious and unforgiving. Sorensen, despite his 4 decades of service and his achievements at Willow Run, found himself on the losing side. In November of 1943, he informed Henry Ford that he wished to be relieved of his duties. The old man seemed not to fully understand what was happening. By March 1944, Sorensen's time at Ford was finished. The production genius who had revolutionized manufacturing, who had helped create the moving assembly line, who had conceived and built the greatest industrial achievement of the war years, was pushed out just as his greatest creation proved its worth. He became, as historians would later note, a casualty of corporate politics, punished for choosing sides in a succession battle and removed before he could fully claim credit for the spectacular success he had made possible. Charles Sorensen did not fade into obscure retirement after leaving Ford. He went on to become president of Willys Overland Motors, where he applied his production expertise to transforming the military Jeep into a civilian vehicle that would become the ancestor of the modern sport utility vehicle industry. King Christian X of Denmark knighted him, making him a member of the Order of the Dannebrog in recognition of the achievements of this immigrant son of Copenhagen. In 1956, Sorensen published his memoirs under the title My 40 Years with Ford, providing an insider's perspective on the company's history that remains an invaluable resource for business historians to this day. He died on August 11, 1968, at the age of 86. The assembly line principles he had pioneered at Highland Park and perfected at Willow Run had by then spread throughout the aerospace industry and far beyond. The methods that critics had called impossible for aircraft manufacturing had become the global standard. The factory that skeptics mocked with a clever nickname had fundamentally and permanently changed how complex products are made. When production finally ceased at Willow Run on June 28, 1945, the plant had manufactured a total of 8,685 complete B-24 Liberator bombers. Ford also produced knockdown kits that were shipped to other assembly plants for final construction. The total number of Liberators produced during the Second World War approached 18,500 aircraft, making it the most manufactured bomber, the most manufactured heavy bomber, the most manufactured multi-engine aircraft, and the most manufactured American military aircraft in history. These records stand to this day. Those bombers served in every theater of the global conflict. They hunted and destroyed German U-boats prowling the Atlantic shipping lanes, protecting the convoys that kept Britain supplied with food, fuel, and weapons. They flew the hump over the Himalayan mountains, the most dangerous air route in the world, bringing crucial supplies to Chinese forces fighting the Japanese invasion. They dropped bombs on Nazi oil refineries that fed the German war machine, on aircraft factories that produced Luftwaffe fighters, on rail yards and bridges and military bases across occupied Europe. They softened German coastal defences before Allied troops stormed the beaches at Normandy on D-Day. They flew missions that historians would later describe as turning points in the air war. The B-24 Liberator was not a perfect aircraft. Experienced pilots found it more difficult to fly than the more forgiving B-17 Flying Fortress. Its fuel tank placement made it dangerously prone to fire when struck by enemy weapons. The high-mounted wing that gave it such impressive range and payload capacity also made emergency landings extraordinarily hazardous for crews. Ditching a B-24 inches water was essentially a death sentence because the aircraft tended to break apart and sink within seconds. But the Liberator had range and bomb-carrying capacity that no other Allied aircraft could match during the critical years when the outcome of the war remained uncertain. It could fly missions that B-17 seconds simply could not accomplish, and it was available in numbers that overwhelmed enemy defences through sheer volume, because factories like Willow Run could produce them faster than the Luftwaffe could shoot them down. By 1943, the B-29 Superfortress was already being developed to replace the B-24. The Superfortress flew higher, carried more bombs, and featured a pressurized cabin that made long missions more survivable for crews. B-29 seconds would eventually drop atomic bombs on Hiroshima and Nagasaki, ending the war in the Pacific. But during the critical years, when victory was still uncertain, the B-24 Liberators from Willow Run helped turn the tide. The plant itself transitioned to peacetime purposes after the war. General Motors purchased the facility in November 1953, following a devastating fire at their Livonia transmission plant, converting much of Willow Run into a hydromatic transmission manufacturing operation. A separate assembly plant was later constructed nearby for automobile production. By the early 2000s, the historic bomber plant section had become a vast warehouse, a relic of a different age in American industry. When General Motors declared bankruptcy in 2009, the Willow Run complex faced demolition. The Racer Trust, established to liquidate GM's abandoned properties, prepared to tear down the historic site rather than leave it deteriorating. A group of aviation enthusiasts refused to let that happen. The Michigan Aerospace Foundation, working through an organization called the Yankee Air Museum, launched a campaign to save a portion of the historic bomber plant. Against considerable odds, they raised enough money to purchase and restore approximately 175,000 square feet of the original facility. Today, the Yankee Air Museum occupies that space, preserving and interpreting the history of Willow Run and the workers who built bombers there. Inside the museum, visitors can see artifacts from the plant's wartime operations, examine a B-24 fuselage built at Willow Run, and interact with actual rivet guns and bucking bars to understand how two workers coordinated to fasten the aluminum skins of bomber airframes. They can experience, in a way that words and photographs alone cannot convey, what it meant to build a heavy bomber every hour while the fate of the free world hung in the balance. The legacy of Willow Run extends far beyond the specific aircraft it produced or the specific war it helped win. The plant demonstrated that mass production techniques could be applied to products of virtually any complexity. It proved that industrial capacity could be mobilized on an unprecedented scale when national survival demanded it. It showed that workers with no previous experience in aviation, including women who had never before set foot in a factory, could learn to build sophisticated aircraft through proper training and organization. Modern manufacturing owes an enormous debt to what happened in that Michigan factory during the darkest years of the 20th century. Just-in-time production, lean manufacturing, the Toyota production system, all trace their roots to the assembly line principles that Charles Sorensen and others developed at Ford. Willow Run was where those principles were stress-tested against the most demanding production challenge of the era, and they emerged triumphant. They called it Will It Run, when it stumbled and struggled and seemed to confirm every doubt that the skeptics had voiced. They called it the arsenal of democracy when it roared to life and proved that American industrial genius could accomplish what experts had declared impossible. The factory that aviation veterans dismissed as automotive arrogance produced more heavy bombers than any facility in the world. The production chief who promised one bomber per hour delivered exactly what he had promised. though it cost him his career. Charles Sorensen deserves to be remembered alongside the generals and admirals who commanded the military campaigns of the Second World War. He never wore a uniform or led troops into combat. He never flew a mission or fired a weapon at the enemy. But the aircraft his factory produced flew missions over 3 continents. The production methods he pioneered revolutionized manufacturing forever. The man who sketched his vision on hotel notepaper in a sleepless San Diego night, who endured years of public humiliation, who was pushed out before he could fully claim his vindication, had nonetheless helped change the course of human history. History has largely forgotten the critics who laughed at Sorensen's promise and coined the mocking nickname for his struggling plant. Their names appear nowhere in the serious accounts of the arsenal of democracy, but the name Charles Sorensen endures, inscribed in the Automotive Hall of Fame, documented in his own published memoirs, preserved in the museums and archives that chronicle American industrial achievement. The lesson of Willow Run is not merely about manufacturing efficiency or wartime production quotas. It is about the courage required to attempt something that experts unanimously declare impossible. It is about the persistence needed to continue when early results bring nothing but ridicule and doubt. It is about the ordinary workers, men and women from every background and circumstance, who built extraordinary things when their nation needed them most. They sketched their audacious plan on hotel notepaper. They built a factory stretching more than a mile. They endured mockery and criticism and failure. They lost colleagues and allies along the way. And then, when everything hung in the balance, when the world needed them to deliver on promises that seemed like fantasy, they built a heavy bomber every single hour. That was the lesson of Willow Run. That was the legacy of Cast Iron Charlie. That was how America became the arsenal of democracy and helped save civilization from tyranny.